We have been working with fractions. We have been comparing fractions, and we've learned how to compare them using fraction bars. We've learned how to compare them using fraction number lines, fractions on a number line. We know that if our denominator is the same, like our Skittles and our Smarties, that all we have to do is look at the number of pieces to compare the size of our fractions. And we know that if our numerator is the same, but our denominator is different, then we think of the brownies and we think of how as we cut a hole into more pieces, each piece has to become smaller. So today we're going to start looking at equivalent fractions. Now, if you'll remember back, equivalent is another word for equal. Our other fancy new word was congruent. But when we're talking fractions, we talk equivalent instead of congruent. So here is my one whole. We're going to use our fraction circles today. So we've got one whole. So think of that like a whole pizza or a whole pie. And I want to know what fraction would be equivalent to 1/4 if I'm working with eighths, okay? So I'm going to put my 1/4 on here. I'm going to flip it right side up. This way we can just see how big 1/4 is compared to one whole. And of course, if we remember, it takes 4/4 to make one whole. I could use all my fourths and lay these over the top and prove that. But what I want to do is I want to see how many eighths it takes to make a fourth. Now, if we were in class, I would have you make an educated guess first about how many you think it would take. But we're going to go ahead and use our 1/8 here. And I'm just going to lay them over the top of my 1/4. And we can clearly see that 1/8 is not equal to 1/4 because I didn't cover up all of the yellow. So I'm going to take another 1/8 and lay it on there. And ta-da! We see that it takes 2/8 to make 1/4, okay? So if I were using fraction bars, which I don't have out right now, I would see that 1/4 bar would stop at the exact same place as 2 1/8. Or if we were on a number line like yesterday, if you remember yesterday's video, we saw that the dots or the points were lined up directly on top of each other, and that told us that our fractions were equivalent also. So let's look at another one. There's my one whole. This time let's do 1/2. So there's my 1/2. Get it lined up on here. And let's see how many fourths it takes to make 1/2. So again, I would have you predict what you think it would be. Clearly, we can see that 1/4 is not equal to 1/2 because I didn't cover up all of the maroon. So we're going to take another, put it on there, and we see that, if I can get them lined up, 2/4 is equal to 1/2. So when we're looking at objects that we're shading in to determine if a fraction is equivalent to another fraction, we want to make sure that they actually cover the same amount of space. So if I were doing this on a worksheet, I would see that if I colored in the 1/2, and then I colored in, I'm going to get rid of my one whole for a moment. So if I were to color in half of a circle, and then if I were to color in 2/4 of a circle, I would see that they actually have the same exact amount of the whole colored in. Now, comparing to 1/2 is going to lead us into the next thing that we will start on Monday, where we're able to quickly decide if a fraction is equal to 1/2 or not. Because when you go into 4th grade, you're going to start using 1/2 as what we call a benchmark fraction to mentally think your way through comparing other fractions. So this is just your quick introduction into how to tell if fractions are equal when we aren't looking at a number line and when we don't have the fraction bars. But we can see that those take up the same amount of space.